Welcome to the Flipscreen tutorial part 4. In part 3 we had a basic template for the Flipscreen game. We had a player controller, we had the tile map, we had a map controller, and we could switch screens. In part 4 we will be extending this to provide the ability to create a HUD, as you can see with the scorebar, which remains static on the screen when you change screens. We will also be adding a room manager so we can separate out the map code from the room code, and that will make it a lot more reusable and component based, and will allow you to create your game a lot simpler. At the same time of doing the room, we will also add screen or room transitions such as this scrolling effect, and we will also add a fade effect. We will also get rid of the need to set the background color in the project settings and instead have a proper background. And in doing all of this, we will be learning about canvas layers, tweens, and viewports. If you have no need for the HUD, that's fine, because at the end of this tutorial you can still create the game without it. First, we will do some housekeeping. In the map game, we used to have a constant which contained the invalid room details, and instead we've now removed it and simply put it as a constant in the room data. That way, in the code that checks for rooms, we don't need to do any additional checks. We can simply return -1 and we will get an empty room. What it also does is when we get round to creating this room manager, which will help replace some of the map code, doing this will make it a little bit simpler. The first thing we will do is fix the game's background. So if you recall, in our map we have a black background, and that is simply because in the project settings we set the background to be black. If we revert back to the normal grey for the editor, as you can see, our game will not be black anymore. So what we will do is go to our game and add a node, and this will be of type canvas layer. Now, a canvas layer is essentially a node that allows you to draw on the screen, so it is not affected by a camera. What we will do is in our canvas node we will add a node of type color rect, and a color rect is just a rectangle with a color, and we will give it the color black. Next, we will go to the layout and set it to be full rect. That means it will take on the full size of the current screen, which, as you can see. We then need to go to the canvas layer and change its layer to be -1, so we can put it behind the screen. Finally, just to keep things neat and tidy, we will save this as a scene, and we will save it into the scenes folder, and we will call it game background. If we look at the camera and we start moving it around, as you can see, the background does not change, so that when we play our game now, we have a black background and it remains fixed no matter where we go in our tile map. Now we will move on to the HUD. So in our game we currently have our tile map that is showing and covering the whole screen, but what we want is this HUD to appear at the top of the screen on top of the tile map, so that when we move around the game it remains static. And that is what we'll do now. So first we will create our HUD. What we want is a new scene, and we just want a node because we won't be positioning it, so there's no need to have any of the functionality of a node 2D. And we will call it UI. Now inside there we need a canvas layer. If you remember, this is a screen thing and it will always appear on the screen. Now our canvas layer will contain our HUD, and our HUD we want it to be some kind of GUI interface. So what we will do is we will add a node called a margin container, and what the margin container does is it is a GUI control that is a container for other nodes, but it allows you to have a margin across its borders. That way you can position things without having to set any kind of offsets on left and right and top for individual nodes. Now in the margin container there is a section called margin, but you never use that. Instead, for the margin container you use the custom constants and you set them here. In our case we don't want a margin, so we just leave it. However, we are still using the margin container as a container for the rest of our GUI. Our HUD is going to have a border around it, a graphical border. So we will add a texture rectangle, not a sprite, a texture rectangle. And in there we will add the outline of our HUD. So if I just copy the files across, as you can see we have our HUD. Now in a full game we will remove these sections in the middle and we will add those as part of a GUI. But for the simplicity of this tutorial we will just add it like it is. So in our scene for the texture we will drag our texture. Now obviously, like I said, if we were creating this by hand we would now add labels and other texture rectangles and maybe horizontal or vertical grids to contain this. But essentially it is still this HUD and we will still have this texture rect, which is the outline. So if you notice, our margin container now has automatically sized to fit our HUD. If we save this scene and call it UI, if you go to our game and add the UI, add an instance to our UI, when we run our game, what you will see is we have our HUD, but it is overlapping the tile map. The reason it's doing that is if you look here in our running code, Godot has added our game to a parent node called root, and if we hover you can see that that is called a viewport. So a viewport is the view to our screen, and every game will automatically get this default viewport. So everything that is drawn will go to this viewport. So our tile map will go to the viewport and so will our HUD. So there's no means of separating those two out because they always go to the current viewport. So what we need to do is create a new viewport called a sub-viewport and put our game inside of that. What we also need to do is we need to increase our screen size. So it is going to stay 512, but its height is going to be 320 plus 64. In other words, 320 for the tile map and 64 for the map. Okay, and the height if our scaled image, where we're doubling it, is going to be this 384 times by 2. So our screen now is the more usual 1024 by 768. So just to show you what happens without a viewport, when we run our game, our screen is changed to 1024 by 768, but our tile map is just showing the whole 384 pixels, so we're seeing part of the next screen below on it, and we're still losing the top. So we need to remove this UI from the game. What we'll do is create a new scene, and we'll call it Game with HUD. We will instance the UI. So we now have a game with our UI. What we now need is a separate viewport, in other words a sub-viewport, to display in this area here, which is 512 by 320. So what we need to do is add a node called a viewport. As you can see, it creates a subview into the screen. However, when you're creating a viewport, they must always be placed inside of a viewport container. And the viewport container holds viewports. Now, I don't know why this is, but that is just how it is. So, we now have a viewport and a viewport container. What we'll then do is we will add our game instance to the viewport. Now, we're getting an error message here saying you must set a size for the viewport. So, if we go into the viewport and set its size to be 512 by 320, sometimes you have to go in and out, sorry. Or even save it for it to get rid of the warning message. Yeah, it's something that's just always been there in Godot. So we now have a viewport showing just the right size map, but you can see it's not at the right place. If we go to the viewport container, we have a lot of properties to manage the game. So we have rectangle, which contains positions, and we also have margin to provide margins. And you can see our size is 512 by 320, and it's got that data from the viewport after we set its size here. So in the container, we could either update the margin or the position, because what we want to do is offset it by 64 pixels. But if we look at the margin, it's already done this for us. And that really is all we need for our HUD. A viewport container containing a viewport of the right size, set its position, and we put the node inside of it. So one thing that might be clear now is we can have a HUD or not have a HUD by simply running the game scene as it is, or running our game without. So if you go to our game scene and run the scene, as you can see, we have our game. Obviously we've got this bottom bar across the bottom because we've set our height to be 64 pixels more. So if we just reduce the height, we will have our normal game. If we now go to our game with HUD, and we may as well set it while we're here, to game with HUD, when we run our game, we now have our tile map correctly showing, or our game, sorry, correctly showing at 320 down and 512 across inside a 512 across screen and 384, and everything works as normal. One thing to bear in mind when you start using viewports is it tends to mess up the screen a lot. If we go to our map scene and look at the code, we have a lot of code to manage the map, and part of that code is it manages, in effect, rooms. So the problem that we may have is if you want to change the tile map from the map to something else, or we want to create a new game and put it in, we will have to modify all of this code, and in effect if we're creating a second tile map we would have to duplicate the code. The other problem is this map is kind of breaking the single responsibility rule. In other words, there is more than one reason to change. So we have map data and maps, but we also have room data. So what we will do is we will extract all of the room related information and put them into a separate room scene, and that way we can swap in and out maps. The other good thing about it is we can then use the room manager to help us create our screen or room transitions and other effects. So there are two ways of doing it. One is to simply create a node called room manager and put it as part of our game, and the other way is to use a facility in Godot called auto load, and this is in effect the singleton pattern. But because singletons end up creating a lot of global data and information that's kind of hidden from view, we will go down the route of creating the room manager as a node as part of the game scene. The first thing we'll do is create a new node 2D, which is similar to the map code. We will give it the name room manager, and then we will save it in our scenes as room manager. We will also add a script called room manager. In our map code, all we want the map to do now is contain information on the map, its navigation data, and then all of the other functionality except the functions that require specific pixel locations. We will take them all out and move them effectively into the room manager. What we also need to do is obviously tidy up references to invalid data. So if you give me a minute, I will update that code and highlight all of the changes. We'll look at a nice feature of a game, which is room transitions. So at the minute, when we move screens, all that happens is it just flips. So what we will do is add some kind of transition to each room, and it will be part of the room manager that you can extend upon. So in this tutorial, we'll be adding a scrolling effect and a fade effect. If we go to our room manager, we need to add a few nodes. In order to fade the screen in and out, we need a color rectangle on top of the screen and fade it in and out. So as before with the background, we will add a canvas layer, and in there we will add a color rect. Again, we will set it to be the full rectangle, which will be the screen size, and we will set the color to black. Okay. As a default, we will set the alpha channel to 0, which means it is not visible. In order to fade the screen in and out, and also to provide our camera scrolling for our slide effect, we need a means of being able to adjust the values over time. So one node available in Godot is the animation player, but that requires known data. If you want to do a similar thing in code, what you need is a tween. So if we add a tween, as you can see, it smoothly animates a node's properties over time. And we will give that a new name. Transition tween. It doesn't need any configuration. In the Room Manager code, we need a few variables. So we want to add a selection of room transition effects. So of course we will keep a reference to those variables. And then in our ready code, we will just ensure that the rectangle is not visible and the alpha is at 0. If you go down to our code where we change room, we set the position here. So what we will do is create a method called transition camera, and we will pass in the new position, a transition type, which will be one of our enums, and also how long we want that transition to go. So in the change room, we will add that transition and the transition length as extra parameters. And we will also update the manage direction code. And obviously we will just call change room and pass in the values. So let's write this transition camera code now. Okay, save time, I've already pasted it in. And what we'll do is we're passing in the new position that we want, the transition type and the duration. So we'll do a simple match statement or switch statement. And if it's a slide, we will call a slide function that we haven't written yet. If it's a fade, we will call the fade function we haven't written yet. And if it's neither, then we don't want any kind of transition. So we just simply update the camera as we did in the code before. Let us now write the transition slide. I will paste in the code and explain it. So if we ignore this paused for now, when we perform a tween, we can do two things. You can either interpolate between a property, in other words, set a value from say 0 to 1, or you can call a method repeatedly. In the case of the slide, what we want to do is, in our tween, we want to call a method, and we want to call a method to change the camera position. So the first parameter is the object that you're talking to, which is our camera controller, and the next one is the name of the method, so that is our set position. And the next two parameters is the start value, so in other words we want to go from its current camera position to its new position, and the last parameter is how long. So this will call our camera's set position every few milliseconds to update the position, so it may well do it every pixel or every 10 pixels. So instead of flipping the entire 512 pixels immediately, or 320, we will be calling this and updating it numerous times. What we then do is we tell the tween to start. Now, as soon as it starts, it goes away and does its work, but it continues, it lets your code continue on. So how we deal with that is there is a method in Godot called yield. And what this method does is it will wait here on this object for this event, and it will not continue on until it is raised. However, as soon as it gets to this line, it will return back to the rest of the code to let it continue. So in other words, we pause it at this line, but let the game continue. And at the very end, we just set the camera position to the new position, just in case the tween was like off by, half a pixel or a pixel in its interpolation. Okay. The next one is fade, and that will do two things. First of all, it will fade the screen to black. It will then change the camera to the new room, and then we will unfade to reveal the new room. So we will be calling the tween function twice as such. So in the first part, we are calling interpolate property, and what we are doing is on our rectangle, which is currently black but has an alpha of 0, we are calling the interpolate property. So we want to update that property, and this is how we do it. We say we want to update the alpha variable of the color variable, and that is how you do paths in Godot. And we want to go from 0, which is invisible, to full alpha, which is fully opaque, and we want to do it over half the duration. Okay. The next parameters tells the tween how you want to progress from one part from the start to the end, and in our case we just want to do it in a linear fashion. We then wait till it's finished. We then set the position of the camera to the new place. So at this point the screen is black, and now we repeat the process, but we go from 1 to 0, so we hide the rectangle. If we go to our game where we call manage direction, if you recall, we've now changed this to support multiple effects. So we now have 3 different ways of doing it. We have the basic flip, we have the slide and the fade. So if we just try out the slide, before we do that we need to just update our ready function. Remember, this is really just a temporary thing to start our map, and we will pass in the parameters. So when we get to our start room, we just want it to simply appear with no effects. So if we run our game now, and we get to the edge of the screen, we've set the transition to be a slide, so it will go from the current position 512 across over a duration of half a second or 1 second. Now, as you can see, the game is completely frozen. And the reason for that is in our game we call this method called pause, and we unset it here. Now, what pause does when you assign it to the tree is it will stop your game from running. And the reason we are doing this is we don't want the player or any other objects on that screen to be moving while we are doing the transition. In other words, we want everything to be frozen, but we do want to update the camera. However, doing so is pause the entire game. So if we look at all of our nodes, they all share one thing in common, and that is they have a property called pause mode. And that property, as it states, is how the node will behave if the scene tree is paused, and the default for every node is inherit. So because every node ultimately goes back to a base object, that base object's default mode is set to stop. So in other words, when pause is called, every single thing will stop, and this is how you create a pause in the game. But what we want is we want the camera, to be continue processing, and we also want our room manager to continue processing. However, in our game, we do not want anything else. So if you run the game now, as you can see, it flips, or slides, and it slides again. Sorry. And we put in the fade, and we'll just make it a second just to exaggerate things, just in case the recording functionality isn't great. When we get to the end of a screen, we fade out, and then we fade in. We fade out, and we fade in. To add your own, you just go to the room manager, and you can put your own in. A more robust way would be to, in the room manager, have a dedicated node for transitions and use those nodes rather than code them all within the room manager. Just to tidy things up, if we go to our game, we will give our canvas layer for the background a nice name. And that is the end of the Godot Flipscreen tutorial. I hope the 3 people who've watched it enjoy it, and hopefully go away and create their own Flipscreen games. What I may do in the future is move this to a separate repository and try and get it as part of the template within Godot, and I will also add some nice instructions so that you don't have to follow the tutorials. But if it's of any use, the basic gist of using this as a template is you need to keep the room manager, keep the camera, you update the map to have your own tile map or whatever map is inside of it, and obviously you add your player node. You can then modify the game to be whatever your game is going to be. And inside of the room manager, you'll modify the transitions. So quite simple. So thank you and goodbye. Okay, so I have updated the code for all of the references. In order to avoid any kind of dependencies between the game and the map and the room, I have added a function in Room Manager called Setup Rooms, and it takes in a reference to the camera and the map, and it then applies it to variables built into the Room Manager called Map Controller and Camera Controller. So this is a kind of dependency injection. So in other words, the room doesn't have to know about the map, the game sends the information to the map. One other thing I've done is created a variable called roomValid, which is used as part of a simple function called validate that determines whether the room manager is being configured or not. And every method that gets called will check to see whether the room manager is valid. And that flag is set after the room has been set up. So it's quite a simple flag to ensure that we do not make any calls when the system is not configured. If we now go back to our game, we can add a reference to this room manager. And if we go to the script, in our ready function, we change the room to the current room. So what we will do is we will add, first of all, a reference to our room manager. And then we will populate the code that we the setup rooms function. Okay, passing in the camera controller and the map controller, which points to the camera and the map. What we'll also do is just put some underscores in front of all of our variables so that we know that we don't want to access these from any other part of the system. So we now have a room manager in our game which configures the map. So in our game code we have references to change room and manage direction, and we have functions to manage direction and change room. Now we don't really want those as part of the game because we want the room manager to look after everything and the game just to look after the game. So we will cut those functions out and we will put them into the room manager, as I've already just done. And these are going to be public functions, so we'll get rid of the underscore. So back in the game, we just change the references to the room manager. The data for each map is stored in the map data. Now, we might not have necessarily a 2D tile map. We could have an isometric map, or we could have a map with different kinds of rooms. So for that reason, we are still storing the room data in the map. And obviously we need some means of accessing this data regardless of the type of map. And we need to access that from the room manager. So in the room manager, we need to make calls to our map for certain bits of functionality. So for example, we need to know what the start room is. We need to know what the room exits are. So back in the back in the map data, we've created a number of helper functions called get start room, get room exits, is valid room, and two methods that work on positions. In other words, these are methods that require knowledge of the internal data structures of our map. So when we create a new map, we need to override these functions. So in summary, we took the functionality out of the map and created a separate room manager which we put into the game, and we moved the functionality from the map into the room manager, and then we created a series of standardized methods in the map code. So if we run our game now, we'll find that everything works exactly as it was before. As stated, in our map we have a set of functions that we want every map to adhere to. In other words, we want every map to start using these functions. As it stands, it isn't obvious to someone who's creating a map how to do this. So what we can do is make use of the inheritance system inside of Godot. So if we take all of these methods and we create a new script file and we call it map underscore base class, we can then create a set of generic functions for these methods that in effect do nothing. We will then give this file a class name and we call it mapmaster. So now when we add things in code, in theory we could add a mapmaster class because this is now a class. But what we're using it for is to become a kind of interface. So if we now go to our map code, instead of extending Node 2D, we will extend mapmaster. And mapmaster has a set of these functions that do nothing. So when you are creating your new map, you'll know that we extend mapmaster, so we really need to provide this functionality. And obviously running the game is exactly the same. There's no change. We've just created a class. The very last thing we'll do in tidying up our game is in our game code we are doing this bit of code as our debug to flip the screen as a means of testing. So if we get rid of that, we can go to our room manager and add it here. And what we'll do is add a variable called debug mode, and in our input we will put a guard statement to handle it. So when you're creating your game, if you declare this variable as being true, then you can have page flipping, and you can always wrap this around a method. And that now makes our game a lot less cluttered. And like we said, all of the functionality for rooms is now in the room manager. All of the functionality for the map is now in the map, and it extends from a base class called mapmaster, which tells every map what functionality it needs.